Hello everyone, this is Ashwini Dashgupta from Cheenta.com. Today, we will be discussing something related to combinatorics. It's a very beautiful part of mathematics. We will talk about a very specific problem, counting rectangles in a grid. After the problem, I will also give you a challenge. So look out for that. If you can solve the challenge problem, there is a little award for the best commenter. Welcome to our channel. Cheenta offers outstanding programs on mathematical sciences, including Mathematical Olympiads, ISI-CMI Entrances, Physics Olympiad, Informatics Olympiad, and so on. We are deeply passionate about all of these subjects. If you are interested, check the link in the description for more details. So what is this problem about? Suppose you have a rectangle. In fact, it's a grid like a chessboard. Okay? So there are 4 columns and there are, let's say, 4 rows. So row 1, row 2, row 3, row 4, and column 1, column 2, column 3, column 4. The question is, how many rectangles are there of all sizes in this particular grid? So I would urge you to think about it. Okay? Think. You should pause the video and think. Now, remember, I talked about example making or miniature. This is a problem solving strategy. I talked about this a few videos ago, so you can check that out as well. We will use it in this particular example. So one rectangle is this one. Of course, when they say rectangle, they're also implying squares. So don't be confused. Squares are special cases of a rectangle. So this entire thing is a big rectangle. Similarly, this small box is also a rectangle. Similarly, this one is a rectangle. This one is a rectangle, and so on. So there are many rectangles. So one way to do this is to enumerate. Enumerate means carefully count. Okay, carefully count. So what we can do is we can first count the 1 cross 1 squares. Of course, there are 16 of them. Right? 16. Now we can count the 1 cross 2 square. So all the squares like this, of this particular form. So we have 1 of them, 2 of them, 3 of them. So each row has 3 of them. So there are 12. Then we can do 2 cross 1 squares, rectangles. So we have 1 of them, 2 of them, 3 of them, and then we have 3 here, 3 here, 3 here. So it's 12 again. So like this, we can carefully count all the different pieces. So this is a very good exercise. This is not the best way to solve the problem, but this is a very good exercise. So it's a challenge 1. Can you give me all possible sizes of rectangles and number of pieces of each size? So I have given you 3 of them. You give me the remaining ones. Okay. So, but this is not the best way to solve it. The best way to solve it is to notice that whenever you choose 2 horizontal lines and 2 vertical lines, whenever you do that, you actually create a rectangle. So suppose if I choose this horizontal line and this horizontal line, and this vertical line and this vertical line, I am creating a rectangle, which is a square in this particular case. So this is the other way. The other way. So choose 2 horizontal lines. There are 5 of them. 1, 2, 3, 4, 5. So out of the 5, choose 2 horizontal lines and then choose 2 vertical lines. Okay? Choose 2 vertical lines, and the order doesn't matter. You just choose 2 of them. So choose 2 horizontal lines, choose 2 vertical lines, and each time you make such a choice, you are actually creating a rectangle. Okay? So out of 5, choose 2 horizontal lines, and here also out of 5, choose 2 vertical lines. So can you tell me the final answer? That's the second challenge. How many rectangles would you get? How many choices of horizontal pairs and vertical pairs you can make? For each of the horizontal pair choices, you will have a vertical pair choice. So you have to multiply these 2. So out of 5, how many? Out of 5, you have to choose 2 here and then multiply with 5, choose 2 here. Can you give me the final answer in the comment section? And here is a challenge 3. So if you have an equilateral triangle, suppose you make 3 equal spaced points like this, and you draw lines like this. Okay, like this. All right, so the question is, how many triangles of all sizes are there? How many triangles of all sizes are there in this grid? How many triangles? Okay, so I hope you loved this particular problem. This is part of Combinatorics, which is part of the Math Olympiad, AMC 8, AMC 10, IOQM, ISI-CMI entrance, all of those things. So check that out. I'll see you in the next one. Take care. Bye.